Wherever you are, you can join us as we lift up our voice and bless the King of Glory. Maybe I will be a true suffers and a kind of your boy. Sense of Fatase or Gia, be anyone in the same.
Welcome to our today's lesson on vectors. Like you always know, my name is Engineer Theophilus Wakame, a tutor with King David College. Okay, in our previous lesson we looked at variance, where we were looking at magnitudes, length, directions and all that. Okay, today we are going to look at vectors. Okay, vectors. We will look at what they are, how we even locate them and everything in a plane. Okay, when you are given a plane, you are asked to take this vector, do this with an add it, get this. That is what we are going to look at. Okay, and so we are going step by step to look at all the necessary activities to be performed on vectors. Good. Now, in science or even in mathematics, we deal with two quantities. Okay, we deal with two quantities. The very first one is scalar, and then the other one is vector. Simple. Only two. Now, when we say scalar quantity, what we simply mean is a quantity that is having only what? Magnitude. We only need the value, not what? The direction. Okay. For instance, they ask you what is your mass, alright? What is your mass? Then you are saying, oh, my mass is 25 grams left, and now 25 grams right, or 25 grams north or east. How come? Nobody can see that. So something like mass, for instance, is a scalar. What is your mass? 25 grams. Simple. You don't care whether left or right. How can you say your mass is even left or right? You see. So with that concept, then we say a scalar quantity, we are only after the value. Okay. Something like time, only the value is needed, right? Good. Now, in the concepts of vectors, there are certain quantities that we need both what? The magnitude and then the direction. Okay, we need the magnitude and the direction. So the direction this time around is going to be maybe northeast, northwest, whatever, like that. Okay. So that is a scalar quantity, has both magnitude and then a direction. Okay, that's a vector quantity. A vector quantity has what? Magnitude, direction. Okay, so this particular video we are going to look at the vector quantities. Okay, vector quantities. Now, okay, now if you have a plane, okay, you have a plane from here like this, and then there is a specific, let's say, zip line. People want to direct some blood to a certain hospital, so they take it this way, going this way to town, say B here. So we can know the length from here to this place. Okay, we can know the length from here to this place. At the same time, we can know the direction in which it went. So let's say this is it. Okay, we can know the length and then what the direction it went. Then we call this what? Here a vector. So if this is town A to town B, then we call this what? Vector what? A B. And then this vector AB is starting from where? Town A and ending at town B. So that's how it's going to be represented. If it's rather starting from town B and coming to A, then we would have said, okay, vector what? BA is starting from town B and coming to A. Are you okay? I'm starting from town B and coming to A. So that is the concept. So this vector AB, we can say, okay, it has a magnitude R and then what? A certain angle, say theta. So you can always either see them representing any vector like this. Okay, Or we can actually get the coordinate of this particular vector and then make it in a vector format. But normally a vector here has what direction? It has direction and then what? Magnitude. Now we can resolve this particular vector into x component, and then we can resolve it into y component, and then that is going to be our new representation. So you can either resolve this vector you have here, vector AB, into what? Its x component, and then you can resolve it into its y component using the sine and the cosine format. So we call it the triangular format, okay, and the rectangular format. Okay, so fine, you can use rectangular format to make it this way, or you can actually represent it using its magnitude and what direction. And even with this, you still have to leave it in the rectangular format. So that one, no problem with that. Okay, good. So like I was saying, where it starts from to where it ends, the arrow shows. Okay, or if I can name this vector, say A, then the vector is going to be vector A, but it's going to be deepened. It's the same thing as saying vector AB. Maybe that's the name of the vector A, but it's going to be deepened. Okay, like D. And then, or I can just underline it like this. However they want to represent, but most books they use the coordinates of where it started from, where it's ending, the value, the labelings of the coordinates for it. So then next we have these two situations. Now, if you have a vector moving from A to say B, okay, then we will represent it as vector A to B with this line. Now, if I ask you to, then if that is so, then get me the vector that is moving from B to A. If I said what? Someone moves from where I am to this next location. So get me a car that will move from the other location to this. I can use the same car. Okay, I can use the same car. All I need to do to that car is that I must turn the direction of what? The car. Are you okay? So it means that the same car that will move from A to B will be the same car that will move from B to A. Just that I will change the direction of the car. So the same way with vectors. If you are looking at vector A to B is this, then definitely the one that is coming from what? B to A, which is vector B to A, is the same as what? Vector A to B in terms of what? Magnitude. But because of concept of direction, this one has to be what? Negated. Okay. So in terms of magnitude, that is the same car, okay, that I'm going to come. But in direction wise, this has to be what? Negated. So we call it a negative vector. If you want the direction to be from A to B, but what you are being asked is rather B to A, all you need to do is to just negate the A to B you have. Then that is going to give you the B to A you are looking for. So how then do we negate this kind of thing? So if I put it in a rectangular format like this, and I want to negate this, so let's say I'm finding vector BA, then it's going to be minus of that. So minus of this one, x and y. This is simply BA is going to be minus of x minus of y. So if this was 2, 4, this would have been negative 2, negative 4. And so if you do everything, you realize that they are the same. Just that one is having the opposite as well. The other in terms of what? Direction. Okay. In terms of direction. So we established that with direction wise, it's very, very important for vectors. Okay. So that's why we are saying that the vector that is moving A to B in terms of magnitude will be the same as B to A. But in terms of direction, they will be opposite. Okay? They will be opposite. Right. So I keep mentioning magnitude I keep mentioning magnitude. Now, magnitude, what is it? It's actually, we are trying to get to what? The weight of this particular vector. For instance, like I was telling you, we know A to B. We want to establish what the length or the distance or whatever. Okay? The only way we can do that is when we put it in triangular format, a rectangular format. When we put it in a rectangular format, then it has to be the X, the Y, resolution. So that is what I said, X and then Y, resolution. So if you want to find the magnitude of what? Vector AB, then the magnitude of vector AB here is going to be the root of the X value of that vector, so X value squared, plus what? The Y value squared. That's going to be the magnitude of what this vector. That is why we say that, okay, in terms of magnitude, both A, B, and then BA will be the same. Because if I need to find the magnitude of BA as well, so this is called magnitude. Magnitude. Okay, that's the magnitude. So if I need to find the magnitude of BA as well, you realize that BA here is going to be the root of, this. So minus X squared plus minus Y squared. And we all know that square of what? A negative number will give you the positive number, just like this. And then the square of negative will give you positive. So it's the same thing. Okay, it's the same thing. So the magnitude of AB is the same as the magnitude of what? BA. But in terms of direction, they are different. They are 180 degrees apart. Okay? Because if you have to locate this one on the Cartesian plane, we all know that Cartesian plane, this is positive Y, positive X, negative Y, and then minus X. That is the Cartesian plane. So with this one here, it means that this vector AB, like I said, is going to have, if I resolve this, resolving is like pulling this line onto the X. You realize that it will lie on this X here. So that means the X is going to be a positive value. And then when I pull this thing here on my Y, it's going to lie on positive Y. So the Y here will also be what? A positive value. But in terms of BA, the negative vector of what? AB, then when I pull this, it's going to be supposed to lie on the minus X. So it means that when I pull it, it will lie on minus X. And then when I pull this, it will lie on minus Y. So hence, that vector BA will be here. Okay? That vector BA will be lying in this plane. So when you look at direction Y, okay, depends on. So when you look at direction wise, this is going this way, this is coming this way. So BA, which is the same as minus of AB, is in the minus region of this. So then this is going to be in this direction, and then this is also going to be in that direction. So the directions are different, though the magnitudes are the same. That is why we call them vectors. Okay, we call it vectors. So that is basically the introduction of what? Vectors. Now, all right. So supposing we have two vectors and they're asking you to sum them or subtract. Okay. So let's move quickly to addition and subtraction of what? Vectors. Addition and subtraction of vectors. So yeah. Let's say, so we are addition and subtraction of vectors. So addition and subtraction. So take it like we have two vectors. Say, let me use this vector AB. So we have vector AB, which is given to me as what? 2 and then 5. Okay. Vector AB is given to me as 2 and 5. That means the x component is 2 and then the y component is 5. And then I'm giving another vector called vector say CD, and that is also minus 1 and then 4. So x component, that one will be lying in this quadrant over here. So we have these two, okay? And the question is asking us to find the vector AB plus vector CD. So we are summing vector AB and then vector CD. And then also we determine vector AB minus vector say CD. Okay, vector AB minus vector CD. And then let me say find the magnitude of vector AB, okay, minus the magnitude of vector CD. So I'm putting everything together so that we'll start. So we are having these three scenarios, alright? These three scenarios. And let's also do a numerical example on what I just taught here, which is, let's say you are asked to find vector BA plus vector DC. Okay, so vector BA plus vector DC. Let's look at that as well. Okay, so in the case of the very first one, we are asked to find vector AB plus vector CD. Okay, vector AB plus vector CD. So now what do we do here? We know our vector AB to be 2 and then 5, and then we know our vector CD to be minus 1 and 4. So if we are looking for the sum of AB plus that of what? CD, then it's just going to be this vector plus this vector. So this is going to be 2, 5 minus a plus, right? 2, 5 plus what? Minus 1, 4. Okay, so 2, 5 minus 1 and then 4. So that's how it's going to be. Okay, now this is how we do the addition. We do it horizontally. Horizontally means that we are going to actually x and x move together, y and y will move together. There is no way x and y will do their own. They are independent. All x's together, all y's together. Okay, so when you are subtracting, you are summing, you are doing all that. X's together, y's together. Thank you. So this one here, we are going to look at this. The x's are going to do their thing together. And you see, so it's almost going to be like the resultant is going to be 2 plus negative of 1. That will be the x part. And then the y part will be 5 plus 4. You see, they're down. So then this will be 5 plus what? 4. So that's going to be how the resultant will look like. So the x's will be together. So then this one here, 2 plus and minus is going to be minus, okay? The positive and negative is negative. So 2 minus 1 is 1. Then this here is what? 9. So we are having this. So 1 and 9. That's it. So the summation of these two vectors A, B, and C, D is simply 1 and then what? 9. It's simply 1 and 9. So you just have to do it this way. Okay. Good. Now in the case of subtraction 2, nothing changes. It just follows the same format. X's and then the Y's. Okay. So this one, let me change this. So with this one here, the one we have to do AB minus CD. Then this one, we know our AB to be 2, 5 minus 1, 4. So with this one, just like we did the additions, the resultant for this is also going to be 2 minus minus, so 2 minus 1, and then 5 minus 4, like that. Okay, so this is basically minus minus, and again will be what? Positive, right? So it's going to be 2 plus 1, which is 3. So 3, then 5 minus 4 is 1. So then the resultant, when you actually subtract, is going to be what? 3, 1. It's going to be 3, 1. Okay. These ones, they are very simple stuff you can actually do. Okay. It's not hard at all. So anything is excess wise, like that. Okay. Now let's look at I, and then the IB. With the I, we are asked to find the magnitude of AB and that of magnitude of CD, and then we subtract. Okay, so that's the subtract the two. Okay, good. So I hope you've copied this. I can quickly. So with the magnitude, we realize that we said earlier that the magnitude is actually what? The root of the x component squared plus the y component squared. So if you are looking for the magnitude of what? A vector AB, so vector AB's magnitude, then that's going to be root of this square plus that square. So the 2 squared plus 5 squared. And so that is going to be the magnitude of AB is going to be root of 4 plus 25. Okay, root of 4 plus 25, and then that is going to be AB is going to be what? Root of 29. So that's going to be root of 29. Then you follow the same format. We are supposed to look for the magnitude of CD. So looking for the magnitude of CD here, then we said that's also root of, you come here, okay, you come this side. So that's going to be minus 1 squared. And we always establish that before you apply square to a negative number, it must be in a bracket. Else, if it is not in a bracket and you punch it, you are going to get a wrong answer. I established that in our previous videos. Okay, so then this one here, CD minus 1, this is what? 4. Okay, so this one is going to be plus 4 squared. So when you have that, then you are going to have the magnitude of what? Vector CD is going to be the root of 1 squared is 1, 4 squared is 16. So root of what? 17. So you only have to just subtract root 17 from what? Root 29. And then the answer you get is actually what they are looking for over here. So you can pause the video and do that simple exercise. So root of 29 minus what? The root of what? 17. Good. So that is very small and easy, no stress, nothing. Okay. So now we can then decide to clean this. Okay, so let's do the last one. So that one is saying that we need to find the magnitude. No, it's not magnitude. The vector BA plus the vector DC. Now we were not given DC, we were not given BA, but we established from the negative vectors that when we are given AB and then we want to reverse it, all we need to do is to minus it, right? Remember we did that example. Very well. So it means that vector BA is actually the negative of vector AB. That is what we know. So then vector BA that we are looking for is negative of 2 and 5. And that vector BA is basically minus 2, minus 5. That's vector BA. As simple as that, not any stressful stuff. Okay. Then same way with DC as well. We know CD. So CD is minus. Okay. We are looking for DC. So DC is minus of what? CD. Okay. DC is minus of CD. Therefore, if we want to get this DC, so DC then is equal to negative of minus 1 and 4. And therefore, if you do this, DC is going to be minus minus of this plus, and then this is minus 4. So the reverse of what you have. Okay. So if we are doing the reverse of what we have, then if we are asked to do vector BA plus vector DC, then it's just summing this and this. So minus 2, 5 plus 1 minus 4. And therefore, this plus this will be negative 1. And then minus 5 plus this is going to be minus 9. Okay, minus 9. So what do you see? You realize that when I reverse the two vectors, the answer is just like reversing the final answer of what? This one. Okay? When I reverse this and this, it's the same as reversing this and this, the final answer. As simple as that. Okay? But if maybe I reverse one, the answer would have changed. Okay? So that's why I want to introduce you to the concept of addition and subtraction of vectors. So if you have been given any vector you need to add or something, it shouldn't be any serious stuff. Okay, it's very simple. Pick the x's, add them, sum them, and all those things. Okay, pick them and all that. Right. Okay, good. So before we will conclude our video, I want to bring your attention to something. We actually do what we call multiplication of vectors with what? Scalars. Okay, multiplication of vector with scalar. Sometimes it's very possible to multiply a vector with what? A scalar. It's not sometimes, always it's possible to multiply a vector quantity with that of what? A scalar quantity. But the question is, how do they do the multiplication, or how do they do the product? Okay, very good. So now let's proceed quickly to that aspect. Then we are cool. Okay, so we are doing multiplication of vector and a scalar quantity. So we are multiplying a vector and a scalar quantity. Very well. So how do we do that? Supposing we have a certain scalar called k. So our scalar is k. And then we have a vector, let me still use AB. We have vector AB as x and y. Okay, supposing we have a scalar k, or maybe scalar can be any number at all. That's why we represent it by k, a constant. So and then we have this vector AB, which is x and y. Very good. And then he asks you to find the value for k vector AB. Alright, k vector AB. What this means is that we are multiplying the scalar k with vector what? A and B. That is a meaning. Okay, that's the meaning. So this is actually saying that vector k multiplying what? The scalar k multiplying vector AB, x and y. So we have this x and y. So if you have that x and y, and then you are supposed to do this. Then what do we do? Scalar multiplies both the x component and then the y component. That's it. So the scalar always multiplies the s component and then what? The y component. So what the scalar does is it multiplies this and multiplies this. So if I have this here, then the answer is going to be kx, ky. That is it. Simple. So that's going to be for the k vector AB, like that. Kx, ky. So numerical example would have been find a vector, find a resulting vector if we have this, something like this. Okay, fine. Where our vector AB, say 3 and then 3 and 5. So this vector AB, 3 and 5, we have to do 2 vector AB. So then this one here, from what we learned, the 2 is going to come in front, so 2 will come in front, then 3, 5. And then kx, ky, so 2, 3, 2, 5. So that's 2 times 3, 2 times 5. Good. So in law, it's going to be 6 and then what? 10. So that is very simple like that. So if you have 2, 3, 15,000, half, quarter, even if it's half, it's just going to be half times 3, half times 5. Any fraction, any whatever is given to you, just multiply it by the x and multiply it by what? The y. Okay. You multiply it by the x and then you multiply it by the y. So that's our multiplication of what? A scalar quantity and that of what? A vector behavior. Okay. So you can be given a whole lot of them, but even in rigid motion, okay? In rigid motion, you can be given this. So you should translate this one on the vector, this on the images and all that. Okay, it's just the application of the same idea. Provided you are given that scalar quantity that you are supposed to multiply with a vector, it just will multiply the x value and then it will multiply the y value as well. So when you do that, you are free and good to go. Simple. So this is the concept of multiplication with a vector and then what? A scalar quantity. Right. So now let us move to the very last aspect of our first video on vectors, which is expression of giving points at column vectors. Okay, expression of giving points at column vectors. Right. So we said we are going to do an expression of what? Column of, let's say, okay, expression of what? Giving points as column vectors. Okay. So you are giving expression of what? Giving points as what? Column vectors. You are giving this to do. Suppose let's say we have a plane, a Cartesian plane here. And then I give you a point here A, and then a point here say B. So this point A here is giving x1, y1. You know we need coordinates, so you know what that is. And then B, we have x2, y2. So we know these 2 points, A and then what? B. Okay. Now they are asking you to find the vector that links the A to B. So let's say someone wants to travel from A to B. What is the vector that is going to link them? So then this one here is just going to be called the vector that is linking A to B. Vector A B. Are you seeing it? Good. Now if I'm giving something like this, then how do I do it? You know, in the initial stages, we were already giving the vectors, and so we're happy, we were doing whatever we want to do with them, good. This time around, we are rather giving the 2 points and asked to find a specific what? vector that links the 2 points. Okay. Now, every point on the Cartesian plane is treated as though, okay, every point is treated as though it is what? A vector that is linking the origin. Okay. So that particular point and the origin are forming a specific what? Vector. That is how it is seen. Right? So this point A here is having a certain link with what? The origin, which is not seen. And then this is also having a certain link with the origin, which is not seen. So for this to be a position, every coordinate, every point on here, on the what? The plane, is actually having what? A link with the origin. Okay, it's forming a vector link with what? The origin. Are you okay? So if the origin is say O, then we can say that okay, this is a coordinate. It can never be written as a vector. You know how we write vectors? X A at the top, Y at the top. So when you treat A alone, A can never be written as what? A vector. So we need to make it be written as a vector before we can be able to get the AB. Alright, so that is why we are using the fact that this point here is having link with the origin. So that we will say that okay, if that is the case, then this one can be a vector, and then this can also be what? A vector. Okay, with the origin. Then when you treat it that way, then we can say okay, then there is a vector for O to A, vector OA. And that one, O is 0, 0, so it will not change the values that is here. So then the vector O to A, then we can say O is given as x1, y1. Okay? It's supposed to be x1, y1 minus 0, 0, but 0, 0 is nothing. So it's like that. Are you seeing it? So if I make it a link with the origin, I can rewrite this coordinate as a vector point. Simple. Then if I make this one also have a link with the origin, then I can also rewrite B that as what? A vector x2, y2. This is the only way I can convert a coordinate into a vector. This is the only way. Okay? This is the only way. In other words, because O and O are origin, you see that in some books they will just tell you O, then hence vector A. So they will just write this as vector A, and then they will write this as what? Vector B. Simple. So vector A and then vector B, and then they go their way. So that in case I want to do anything with them, I can just pick it that way. The vector A and B. ASAP. Okay. Now, if you have 2 points or 2 vectors, and then we want to link them together, 2 vectors are on their own. Okay. So, for instance, the way A was on their own, B was on their own. Now we want to link the 2 of them using this vector AB. Right? If you want to do that, then we say that okay, to link 2 different vectors, then it must always be what? The destination vector, minus what? The source vector. I'll explain that soon. The destination vector minus the source vector. So if I'm having, let's say, AB, with the arrow, I already explained that this arrow means that the vector is starting from where? A and ending at what? B. Okay? It's starting from A and ending at what? B. So when I say destination and source, you understand? Destination is where it's ending, source is where it's starting from. Okay, just take that one as a guide. So destination is where it's ending, source is where it's starting. So if I'm doing C, D, Then in this case, B becomes my what? Destination, and then A becomes my source. Please take note. B becomes my destination, A becomes my source. So if I want to express this as positional vectors, right, then it's going to be what? The destination vector, which is B. So it's like vector B. And I said vector B should also be written as what? Having a link with the origin. So then this one is going to be OB minus this OA. And this one will never change. This will never change. Or you can say some books vector B minus vector A. It doesn't change anything. Okay. So then this destination source. Same way if I'm doing for CD, then this becomes destination source. So then D vector, so OD minus what? OC. Simple. Like that. Are you okay? So in this case, we have our OA as what? X1, Y1, and our OB as X2, Y2. So what do we mean by that? Then it means that, oh, okay, then when we are linking these two, vector AB is destination source. So it's supposed to be OB, which is what? X1, X2, Y2. So this is going to be X2, Y2 minus vector OA is already there. Vector OA X1, Y1. So X1, Y1. Then whatever result you get will be for vector AB. As simple as you see it. Very well. So let's take a numerical example. I give you vector P to be 6, 1. Coordinate P or point P to be 6, 1. And then point Q to be 7, 2. Okay? So I give you point P to be 6, 1. And then point Q to be 7, 2. Then I'm asking you to find vector PQ, and then find, that's I, and then I find 2 times vector PQ, application of what we did, and then the I'm asking you to find 3 times vector QP. Okay, so we are having this situation. So you can pause the video and try and see if you can do it. Alright, so I guess you have answers. Now let's proceed. Good. If you have this and that, and then we ask to find P and Q, then you take inspiration from what we did here. Okay? We said for every vector, we have destination and source. So this one here, this is the destination, this is the source. So vector PQ here would have been what? OQ minus OP. Okay, so this is OQ minus OP. So OQ minus OP, yeah, then what would they be? OQ is this one, this point now written in a vector format. So PQ, as you see, is going to change to 7, 2, right? That is OQ minus OP 6, 1. So this one here is going to be the 7 minus 6, that is 1. Then 2 minus 1, that is also 1. So then if you decide that, then this is going to be P2. Okay, very simple like that. There is no complexity in the very first part of vectors. Okay, So that is very simple. So the next question is asking us to find 2pq. So 2 times vector pq is just like saying 2 times what? 1, 1, right? So then this answer is 2, 2. We did that already. This is going to multiply that. This is going to multiply this. So you are going to have 2 times 2. Very simple. Now the third one is saying 3qp. Okay, 3qp. Now, someone might say, okay, the qp, the destination is p, and then the source is q. So I'm now going to do p minus q, and then you get -1, -1. Fine, that is also cool. But from the very first beginning, we said that when we have pq and then you are trying to find qp, it's just the reverse, right? pq, qp, so it's reverse. So we all know that qp vector is the negative of what? Vector pq. So if that is the case, then this is just like saying I'm multiplying 3 by that. So a vector qp will be negative of this value, which is -1, -1. You see that? -1, -1. So 3 times this one. So 3 times -1, -1. And then it's going to be -3, -3. So you can either choose to do it the reverse format, or you can just pick the qp alone and then do it vector op minus vector oq. Okay, vector op minus oq. So op is 6. So 6, 1 minus the oq is what? 7, 2. So this one here is going to 6 minus 7, -1. 1 minus 2 minus 1. So eventually you are ending up here. Then you multiply it by what? 3. And then you have those concepts. So in fact, this video has been really long and lengthy, but we've established lessons of things that are not even much more, should I say, difficult. So if we have this situations, you are giving additions, you are giving multiplication by a vector and what a vector itself is. Okay, so with that, then what do? We say we can actually finish what we have. Then we do that. So thank you very much for joining this video. Keep your fingers crossed as we move into the next video, where we are going to look at the conclusion aspect of what? Vectors. We look at parallel, perpendicular ones, we look at dot product, scalar product, in the angle between two vectors, like that. Then after that, we look at how we can resolve and solve situations. So see you there. Have a blast. Bye bye.